Hello students, good evening all. So welcome back to our sessions. So today is our session 3 of chapter Indefinite Integrals. So we have already had a quick discussion in this indefinite integrals. So we already have had two sessions, session 1 and session 2, where in session 1 we just had a quick discussion like introduction to integration, integrals and all. And then we have seen with a very basic elementary integration part and some standard results. So that part and all we have covered in our session 1. So when coming to the session 2, we have started with methods of integration. Right, so in our session 2, we focused completely on the substitution method, and in that substitution method, we have done questions related to that, and along with that, we have even seen the standard substitutions and all. So coming to our today's session, that is session 3 of our indefinite integrals. So it's obvious that it is our continuation part of our methods of integration. So we'll just have a quickly overview of today's session. So integration by substitution is one of our methods of integrals which we have covered in our previous session of indefinite integrals. And along with that, we have even seen some standard substitution. For example, if we could have some function that is root over x square minus a square. So if you could see any of this type of function in any of our questions, then we can directly substitute in place of s. We can substitute a sin theta or we can substitute a cos theta. So this is where we have seen some standard substitution. So for this typical function, this will be the corresponding substitution here. So likewise, there are few more standard substitutions which we have covered in our session 2 of indefinite integrals. So coming to our today's session of indefinite integrals, we are going to start with our next method of integration, that is nothing but integration by parts. Right, so there is one more name for this integration by part, that is nothing but UV integration. We will be saying UV rule integration. So that we are going to learn in our today's session. So this is our starting part of today's session. We are going to start with the method of integration by parts. Right, so along with that, we will be seeing some questions related to this concept of integration by parts. And the next is integration of particular forms. Right, so we'll be having some particular forms of functions. So in general, if we talk about, it can be some exponential form, it can be a logarithmic form. Right, so for those particular forms, there is a direct integration. So that we are going to see here, that is integration of a particular forms. So in this particular forms, it can be a logarithmic form or else it can be a exponential form. So like that, we'll be seeing the integration of these typical particular forms of functions, right? So after the integration of this particular function, the next step we are going to, the next method of integration is integration of rational functions, right? So just keep it aside this integration part and let's focus on this rational functions. So to do this integration of rational functions, first we should be aware of what is rational function. Yes or no? It's a basic common sense, isn't it? So if you recall your chapter functions which we have discussed in our 11th standard, there while we are discussing the concept of common functions. Right, so while we are discussing in the concept of common functions, we have seen rational functions and we have learned this rational functions. Right, so rational functions is nothing but it will be in a typical form of a fraction. Right, so it will be a form of fraction, that is f of x by g of x, where both my numerator as well as the denominator will be my polynomial functions. That is both f of x and g of x are polynomial functions where my g of x here is not equal to 0. Right, so that is my basic definition of my rational function. Right, so before getting into the integration part of this rational functions, we should be clear with this definition of rational functions, right? So whenever we see a rational function should be in a fractional form, both the numerator and the denominator will be a polynomial functions where the denominator g of x should not be equal to 0, right? Which means if you could find any functions in this particular manner, so those will be considered as our rational functions, and then we'll be having a separate methodology to integrate the rational functions. So that we are going to cover, right? So in and overall, so these are our 3 typical methods of integrations which we are going to cover in our today's session of indefinite integrals, right? Along with the methods, we will be going to solve questions related to each of the methods which are given here, right? So let's quickly get started with our today's session with the method of integration by parts. So this is our next method after our substitution method. Here comes the second method, that is integration by parts, right? So if u and v are 2 functions of x, so here we are having 2 functions. So generally what we'll be having, integration of f of x, which means f is a function in terms of x variable, f is a function in terms of variable x. Yes or no? But here in this case I am having 2 functions u and v, right? Both are the functions of variable x, right? So if I have both of these functions, then I have to follow my rule of integration, that is nothing but I will be calling here a UV rule of integration, right? So this UV rule of integration, I will be having 2 functions here, u and v, right? So both these functions are functions of variable x, right? So now what will be my UV rule of integration here? My UV rule of integration is nothing but, so amongst this u and v, I am taking one is my first function and the other is my second function, right? So then my UV rule of integration is nothing but first function, right? So first function into integration of second function. So first function into integration of second function whole the minus integration of differentiation of first function, that is differentiation of function u, differentiation of first function into integration of second function, right? So again here one integration is there, so this whole again has to be integrated with dx, right? So instead of taking u into integration of v, so it will be like typically it's like difficult to remember our UV rule of integration. So instead of that, if we remember as first and second function, it will be like a rule to remember easily, right? So here u is my first function, v is my second function. So what is my UV rule of integration here? First function into integration of second function, the whole minus integration of, so the whole integration of differentiation of first function into integration of second function, right? So this will be my rule of integration, UV rule of integration. So it will be easy for us to remember if we go by this one first function and second function instead of u and v. So now here comes the catch. So how we'll be deciding which function is first function and which function is second function amongst this UV, right? So to decide first and second function amongst our functions u and v, there is a chain rule here. So that is I late. So my priority will be based upon this I late. So I here indicates inverse trigonometric functions. So if amongst u and v inverse trigonometric function is given, then I am going to assume that inverse trigonometric function is first function. And the second priority goes to L, that is logarithmic function, right? And third goes to algebraic. So algebraic, and fourth goes to trigonometric function, and the fifth, that is E, that is exponential function. So the basic rule to decide which is the first and which is the second function amongst our UV, we'll be following this rule of isolate. Right. So this is a basic rule. But while we are solving it, what happens is, even if we follow this rule of isolate, sometimes what happens, we'll be end up having V as such function where we couldn't integrate simply. Right. So then what we can do, we can rearrange them. Right. So we can exchange U to V, and like if for suppose my U is second function and V is first function. Right, here I am just explaining with for an example. So here my U is second function and V is first function. But while applying my UV rule of integration, so first function, that is V, integration of U dx. So this U is such function where I couldn't integrate it. Right, so my U is the second function, but I couldn't easily integrate this U. But I can integrate this V. In such cases, so it's like exception we can say. In such cases, what I can do, I can eliminate this isolate rule and I can directly take my U function as first function and V function as second function, and I can apply my UV rule of integration. Right, but that will be an exception. Depends if in that case only where I couldn't integrate my U function. Right, so that will be our exception case while applying our UV rule of integration. Right, so in this integration by parts, we are having two rules, that is isolate here. So while selecting the first and second functions, we will be following by isolate, and the second rule here is our UV rule of integration. So by combining these two, the entire method of integration here is called to be integration by parts. Right, so now I hope you are clear, but there is one exception case as I mentioned. So let me explain you the exception case once again. So by applying my isolate rule, I end up having, right, so this is my integration. Right, so by applying my isolate rule, I end up having my V as first function and U as second function. So now what will be my UV rule of integration? First function, that is V, into integration of second function, that is integration of function U, minus integration of differentiation of first function, that is dV by dx, into integration of first function. Sorry, integration of differentiation of first function into integration of second function. So integration of second function is U here. So U dx, and the entire thing again dx. Right. So in most of the cases, we could easily find the integration of whatever the function given U here. But in very rare cases, what it will happen is, it is not possible to find this integration of function U. In that special cases, what we can do is, instead of writing like this, I can take my U function as 1 and V function as 2. Because I cannot integrate this function U, whereas I can easily integrate and get my result for function V. In that case, I can replace it. So no worries, the result and the answer will be the same for both of the cases. Right, so it will be up to us, whichever the easiest integration function, that if we pick, it will be easy to solve the procedure further. Right, so this is our UV rule of integration, and the method entirely is called to be integration by parts. Right, so I hope you are clear with it. So let's solve a question here which is related to our integration by parts. So the only thing in our integration by parts which you have to remember is the selection of first and second function, and then directly apply your UV rule of integration. That's it. So let me write the UV rule again. So U and V dx. So I am considering u as first function and v as second function. So this will be equal to first function into integration of second function minus integration of differentiation of first function into integration of second function and the whole integration here. So this is my UV rule of integration, that is nothing but my integration by parts. So just identify guys, so from the given question what will be your u function and v function, and then so my suggestion is whatever we can easily integrate that, you can fix that to be our v function so that we can simply solve it. So please try and solve this question guys and let me know what's your answer. If you just take 2-3 minutes, so you can just give it a try, and if you are facing any troubles, I am here to help you. So quickly guys, give it a try. So you can start, first we have to start by first function and second function by taking our rule of Euler. Then you can fix amongst these two functions, which is our first function and which is our second function. Quickly give it a try guys. So one function here is 1 plus x and the other function is log x. So can you tell me amongst these two, what is your first function and what is your second function? So it's easy, by looking at the question itself, we can say simply we have to follow our Euler. I is inverse trigonometric function, L denotes logarithmic function, A denotes algebraic function, and T denotes trigonometric function, and E denotes exponential functions. So by applying this, you can simply predict amongst these two which will be our first function and which will be our second function. So quickly tell me guys, amongst these two functions, which is first function and which is second function here? Anyone? So before solving it, just let me know what is your first and second function amongst the given two functions in the question. Anyone? See, it's not a separate thing. So x log x is a entire one function here. Here log is not a separate thing. So here the functions are integration of 1 plus x into log x dx, which means 1 plus x is one function and log x is another function, and this entire dx means it's a integration. I think you just identified the question, the functions in the question wrongly. So can you look into it right now? And now you can categorize amongst these two functions, which is your first function and which is the second function. What happened guys? Tara, Shivani, Shivaranjani. Yeah. So first function will be log x. So obviously second function will be 1 plus x according to our rule of Eilert. So now quickly apply our UV rule of integration, that is our integration by parts. So first function into integration of second function minus integration of differentiation of first function into integration of second function. So first if you write this expansion, then you will be understanding how to simplify it further. So this is the first step to identify, and the next step is to expanding our UV rule of integration here. Exactly, Shivani, correct. So first function log x and second function 1 plus x. 1 plus log x. Okay, you have multiplied. So there is, okay, if you are solving like that, no issue. It's up to you. But if you have actually expanded it further, but it will be easy if you take it directly as it is. Because while doing here, again, we have to simplify it because you have just multiplied this thing, right? So here, that thing should not be done. So if you have multiplied it, then it should become log x plus x log x. Right, it will be turning out to be like that. So this will be a separate thing and this will be a separate thing which you have to do if you want to multiply and do it. But I will suggest it will be a bit lengthy. So before you can follow as it is in the functions which are given in the question. Right, so my first function here will be log x. Okay, Shivani, no issue. Okay, so my first function is log x here and second function is 1 plus x. So there are some students which they'll be multiplying and then they'll be interested in solving it, but no issue. It's up to you. But as they have given into two functions directly in the question, we just follow that way. No issue. Okay. So can you guys simplify this and let me know what's the answer? So I'm just writing it here. What is my first function and what is my second function? Okay, someone has given me the answer. So, Shivaranjani, okay. X log x plus x square, okay. X square by 2 log x, okay. Minus x square by 4. Okay. Correct. So, plus c. Yeah, you added plus c also. Okay, fine. Fine. So, what about others, guys? So, I'll just give you quickly 1 more minute and then I'll just explain you how to solve this. So, the expansion, the UV rule of integration, we'll just remember it as in a flow, like first function into integration of second function minus the whole integration into differentiation of first function into the integration of second function. So, likewise, in a flow, we'll be remembering the thing. So once you just cope up with it and start solving questions related to integration by parts, then it will become a habit to you to do this UV rule of integration. So I'll just help you. So here, what is my first function? That is log x, and what is my second function? That is 1 plus x. So I'll just write down my UV rule of integration first. That is first function log x into integration of second function, that is integration of 1 plus x dx. So the whole minus integration of differentiation of first function. So what is differentiation of first function? That is differentiation of log x first function into integration of second function, that is integration of 1 plus x dx, and the whole again with dx. Right. So this is our expansion of UV rule. So let's simplify it. So log x, it will be remaining as it is, and integration of 1 plus x, that will be x plus x square by 2. Right. So whole minus here and then integration of, so what is differentiation of log x? So differentiation of log x will be 1 by x. So 1 by x. So integration of this part, that is x plus x square by 2 dx. So here I can further simplify this. Yes or no? So let's simplify it further. So log x, x plus x square by 2, that will be remaining as it is. So minus integration, if I multiply by 1 by x, this will be becoming 1, and so this will be turning out to be x by 2, right? So this whole dx. So this will be our final step now, that is log x, x plus x square by 2, that will be as it is. So minus the whole minus, here I am writing the integration part of this. So this will be x plus x square by 2, and in denominator we are already having 2. So 2 into 2, 4. So x square by 4 and whole constant c. So what is my result here? This will be log x into x plus x square by 2 minus x square by 4 plus constant c. Right, so this will be my result here for my first question, that is using my method of integration by parts. Right, so I think most of you got this one. So if you are having any doubts in this question, you can let me know, so that we can just have a discussion and I can clarify your doubts. If not, we can move ahead. I hope you guys are clear with this. So if you are clear, we'll just move into the next part. So we'll just move into one more question. Okay, I think you're clear. So let's move on to one more question. So this will be a bit advanced. So here there will be a trick. So just read the question, try to understand it, and how can you apply and solve this given question. So give it a try. Just think for 2 to 3 minutes, and then I'll just give you a hint. So this will be a advanced level. So just give it a try. So the methodology will be the same. Okay, got it for the previous one. Okay, fine. So this question is a bit advanced level, as I mentioned. So just give it a trick. So we doesn't know how to directly do the secant cube x. And one more thing, in indefinite integrals, we'll be getting different types of answers because there is no definite answer here, right? So based upon the options, we'll be going. So that's why it will be difficult, like which method we have to follow while dealing with indefinite integrals and all. So what I'll do, I'm having here the function secant cube x. I'm going to split this as secant x into secant square x dx. So now I can apply my integration by parts. So now select amongst these two functions which will be my first and second, because both are trigonometric functions. So as I mentioned, apart from ILATE, there is one more trick to choose first and second function. So now you have to apply that, and then you have to select amongst these two functions what will be the first function and what will be my second function. Come on guys, quickly start solving it. Yes, so Shivani already given here. So first function will be my secant x and second function will be my secant square x. So now directly apply our integration by parts and try to simplify this. So here my first function is secant x and second function is secant square x. So let's just apply our UV rule of integration, that is first function into integration of second function minus the whole integration of differentiation of first function into integration of second function. So we are already aware of what is our first and second function. So simply apply and see what will be the result. Okay, 1 by 2 secant x tan x plus log secant x plus tan x. Okay, correct. Perfectly correct. Shivaranjani has already given. So what about others guys? So quickly take 2 more minutes and then we'll just have a quick discussion on this question. So let's just solve this question. So this is our first function secant x and second function is secant square x. So what will be our UV rule? So first function, that is, so secant x. So first function into integration of second function. So my integration of secant square x dx is nothing but equal to tan x. So integration of secant square x will be tan x minus the whole integration of differentiation of first function, that is differentiation of secant x is nothing but secant x tan x, right? So into integration of second function, again integration of secant square will be tan x, so whole dx here. So this secant x tan x will remain as it is. But here I am going to have secant x into tan square x. Right, so here all the terms in secant. So I am just going to convert my tan square x into secant square x. So we are having the identity, that is secant square x minus tan square x is equal to 1. Yes or no? So from here, in place of tan square x, we can substitute secant square x minus 1. So let's do that. So secant x into tan x minus integration of secant x into secant square x minus 1 dx. So let's simplify this term. So it will be secant x into tan x. So minus here secant into secant square, it will become secant cube x and minus secant x dx. So here if you observe, we are having again the same question term here. Right. So now what I am going to take is, I am going to take my given question to be I. That means I have actually simplified my I and it end up having like this. Right. So again in between here in my RHS, I am having my I. So I can replace that with I. Yes or no? So let's do that. So if I replace here I and I'll bring that to the other side, then it will become I plus I. And my RHS will be secant x into tan x. So minus into minus plus integration of secant x dx. Right. So this will be my RHS right now. Right. So I am just doing it here. So this will be 2i and secant x into tan x will be there. And here comes the next part, that is integration of secant x. So integration of secant x is nothing but log of secant x plus tan x and constant c will be there as it is. So now I want to get my integration for I. So I will be equal to 2 will be going to be the other side. So 1 by 2 into secant x tan x plus log of secant x tan x and to the whole constant c plus constant c. Right. So this will be my answer here, and this is how we'll be solving these kind of questions where we'll be having the secant cube x and all. Right. So the only overall funda here which we have to remember is our application of our integration, that is our method of integration by parts, that is by applying our UV rule of integration. Right, so once we completely remember our UV rule of integration, that is first function into integration of second function minus the whole integration of differentiation of first function into integration of second function. Then when we could remember this entire thing, then it will be easy for us to simplify our questions using our method of integration by parts. Right, so let's move on to the next integration method, that is integration of some particular forms of equation. Right, so let's see the first one here. So this is related to our exponential function here. Right, so if the integral is of the form, so if any of the integral is in the form, that is integration of e power x to the multiplied by f of x plus f dash x. So e power x also be there as well as f of x plus f dash x. Then we can directly use this formula for this form of function. This will be directly equal to e power x f of x. So how we actually solve this? By applying our integration by parts only, because this function is in terms of x. This function is also in terms of variable x. So amongst these two, we have to select our first and second function, and then we have to apply our integration by parts, and we have to simplify the whole thing, and then we'll be end up having the result. So instead of doing that whole like typical derivation kind of thing, we can simply apply our this typical form. Right. So if you could see any of the integral of this form, we can directly apply our this particular result and we can write the answer within seconds. So integration of what is the function? So it will be integration of e power x into f of x plus f dash x dx. Then my result will be e power x into f of x. Right. So e power x into f of x, and as usual plus constant c. So this is one form. So there will be one more form here. So that is our second form of equation, second form of function. So if the integral is of the form. So initially our integral form is in terms of exponential, but now it's in algebraic. So let's see. So if it's a function of form, if it's an integral of form, x into f dash x plus f of x. So here you can see the x variable is with only the function f dash x, not with f of x. So if you are having an integral of form x into f dash x plus f of x to the whole dx. If we want to do the integration for this, so again the same thing, if we want to simplify and do it, we have to take our UV rule, check the islet, and we'll be applying our UV rule of integration and then simplifying it. Yes or no? But instead of that, we can use our result, derived result, that is nothing but if an integral is of this form, it will be directly equal to x into f of x. So if it's a e power x, then it will be e power x f of x in our previous form. If it's a x here, but in e power x, it will be for the whole of the function. Right, but here x is for only the f dash x. So that's you have to, and these are our two different forms of integration. So without applying our integration bypass, we can directly use these results and we can directly solve our question within seconds. So let's see questions related to this. So quickly see and write the solve this question and let me know the answer. Come on guys, I have already given the forms of equation. So forms of integral and the corresponding result. So you have to identify what is function f of x and f dash x, and then you have to quickly write the answer. So check the given function is in which form of integral, and then what will be the corresponding result. So come on guys, why it's taking too much time? Quickly let me know the answer. So see, given function is in exponential and see which form it belongs to. Given integral is of which form? What happened? No one replied. Arun, Shivani, Lakshmi, Shivaranjani, Tara. See here, what is the integral form here guys? So here we are having e power x. and log x here plus 1 by x and the whole dx here. Yes or no? Right. So here if you observe, if I have taken my f of x function, so this is equal to log x. Then what is my differentiation of function log x? That is f dash x. So differentiation of function log x is nothing but 1 by x. Which means here I am having my given integral in the form of e power x the whole into f of x plus f dash of x. Right, so just now we have seen what will be the result if we have any integration of this form e power x into f of x plus f dash x. It is directly equal to e power x f of x plus constant c. So in this question, what is our function f of x? So function f of x here is nothing but log x. So here the result and the answer is nothing but e power x log x plus c. So the integration of given integral is nothing but equal to e power x log x plus c. So this will be the answer here. So I hope you guys are clear with this. So if you are clear, we can just move ahead with our next question. So here comes the next question, guys. So quickly read the question and see. And identify which form is this, the given integral, and what will be our result and what will be the answer here for this. Quickly. So here, if we observe what is the given integral, here it is integration of x into secant square x plus tan x and the whole dx. So if we want to simplify this in our normal method, here we are having two functions which are both in the variable x. So here it's obvious that we have to apply our UV rule, that is our integration by parts, and simplify it. So instead of that, we have just seen our proved results. So just identify this form, which which form it will be belonging to, and write the corresponding answer, corresponding result for this. So see here, if I have taken my f of x function to tan x. So what is my differentiation of tan x? That is nothing but f of dash. F dash of x. So tan x differentiation is nothing but secant square x. So by comparing this, so what is my given form of integral? So this is x into f dash x plus f of x into whole dx. So what will be the result which we have seen previously? So this will be equal to x into the function f of x plus constant c. So in this particular integral, what is my function f of x here? So my function f of x is nothing but tan x. So my integration here will be equal to x tan x plus constant c. So this will be my final result according to the results which we have seen. So this is x, the integration of the given form will be equal to x tan x plus constant c. Right. So I have just, we have discussed here our integration by parts and some of the results which are related to our integration by parts. Okay, Shivani has given the answer x tan x. Okay, correct. So let's get into our next question, guys. So here comes the question which is related to our substitution, standard substitution. So in our previous one, we couldn't solve any questions related to our standard substitution. So here I just plan to give you a question. So let's try this question, guys. Okay, got it, Lakshmi. Okay. So try out this question, guys. So here they have given both the LHS and RHS of the question. We just have to prove here. So just in the beginning of the session itself, I have given the example of this particular substitution. Like not in the denominator part. If it's a denominator, it will be a different substitution. So just give it a thought. If not, I'll just give you the substitution, because we should be only aware of the substitution. Then we can just substitute and we can simplify it. So here, what is our given function? So this is 1 by x square minus a square under root. So as this in the denominator, so what will be our corresponding substitution? So my corresponding substitution in place of x here will be a secant theta. So I have already given the substitution here. So now it's up to you. You have to simplify it. After substituting it, how we'll be solving it, that's also very, very important here. So we already know these tables, because the function will be given and the corresponding substitution will also be given. That entire table we have already seen. So when my function is integration of 1 by root over x square minus a square, then my corresponding substitution in place of x will be equal to x equal to a secant theta. So now you have to substitute this a secant theta in place of x, and you have to further simplify this. Okay, Shivaranjan has already given what will be the substitution. Good. X equal to a secant theta. So quickly substitute it and tell me what will be the result function you are getting. So just simple substitution and simplification, guys. So what you'll be getting after substituting in place of x, a secant theta? Can you just tell me that? So what is our substitution? A secant theta. So let's substitute and see. So this will be dx by x square. That will be a square secant square theta minus a square under root. So here what can we identify? We can pull out a here. Yes or no? Right. So I can square theta minus tan square theta is equal to 1. So from here, secant square theta minus 1 can be written to be tan square theta. So integration of dx by under root a square tan square theta here. Right. So here in place of a square tan square theta, if I take common, then it will become dx by a tan theta. Yes or no? So this tan theta can be written as sin by cos and we can simplify this. Right. So this will be my simplification. So let's do it further, guys. So I have solved it half of the question. So just give it a try. The remaining part. Yeah, you have to substitute dx also. So I just simplified right until now. So in place of dx, you can substitute that also. Shivani has given. So here we have substituted x, that is a secant theta. So we have to substitute dx also. So dx will be equal to a secant theta differentiation is secant theta tan theta. So this part you have to substitute d into d theta. So this part you have to substitute in place of dx and you have to simplify it further. It will be simplifying it further. Right. So it will be a secant theta tan theta d theta by a tan theta. So tan theta will be getting cancelled, a and a will be getting cancelled and will be remaining with only one term, that is integration of secant theta d theta. So this will be our last simplification here. So initially we have substituted in place of x a secant theta. So after simplifying that we end up having this, and after in place of dx we can again substitute a secant theta tan theta into d theta. So after substituting that we end up having the integration secant theta into d theta. Right. So let me erase this part. So what is our final simplification step? So integration of secant theta d theta. What is our substitution? X equal to a secant theta. So now what is this integration part here? So integration of secant theta will be equal to, so it's a direct formula, right? So in our direct standard result we have seen. So this will be log of secant theta plus tan theta. And plus constancy will be as usual. But here when we are writing in our last terms, it shouldn't be in terms of theta because our question which is given is in terms of x. So we have to again rewrite this in terms of x. So how we'll be writing in terms of x? So what is our secant theta? So from here secant theta will be equal to x by a. Yes or no? Right. So if secant theta is x by a, so we are having a relation, that is our identity for secant and tan, that is secant square theta minus tan square theta is equal to 1, where we have to find tan square theta. Right. So that will be secant square theta minus 1. So it will be x square by a square minus 1. So this will be equal to tan square theta. So let's take the LCM. So x square minus a square by a square will be equal to tan square theta. So if tan square theta here is equal to x square minus a square by a square, then what about our what will say? So what about the tan theta? So here log of secant theta here will be equal to x by a, direct substitution, and tan theta will be root over x square minus a square by a plus constant c. So anyways, a is a constant here. Yes or no? So as a is a constant, so we can take that and we can add that to the constant. So it will be directly equal to log of x plus x square minus a square plus c. So here, while solving this, the only thing we should be aware of it will be the substitution. So if this is my function which is given, what will be my corresponding substitution here, and the further will be the same thing, a simple simplification, right? So this is all about this question. So if you have any doubts, we can discuss that. So if not, we can just okay, before discussing the next concept, we'll just wind up here for our today's session, and the remaining concepts, remaining methods of integrals to solve the integration, that we are going to discuss in our next session of indefinite integrals. So I hope you guys are fine with this session question, guys. So please let me know if you're having any queries and like any doubts. So it's nothing but a simple simplification which we have done, but the only thing we should be aware of is should be, if we are having a function that is 1 by root over x square minus a square dx, if we are doing the integration of this function, in place of x, the substitution should be a secant theta. So this should be, we should be aware of it, right? So that is nothing but we should be thorough with our standard substitutions which we have seen in our previous session of indefinite integrals. So that's all for today, guys. So we'll just continue the rest in our next session of indefinite integrals. So thank you.